Children, today we are going to discuss in this video 16th group interhalogen compounds preparations, properties and uses. Interhalogen compounds preparation, properties and uses. Now, how to preparation of interhalogens? Here they are prepared by direct combination or action of halogens on lower interhalogen compounds. How to prepare? Either directly combinations of halogens or the action of halogen on lower interhalogen compounds. So example here say chlorine and chlorine. Here both are equimolar ratios. Heated at 437 kelvins form the chlorine fluoride. Like chlorine and chlorine again, the excess of chlorine reacts with 573 kelvins to form chlorine trifluoride. Iodine and chlorine in equimolar ratio reacts to form iodine chloride. Bromine and chlorine reacts equal molar ratio to form bromine trifluoride. Bromine and chlorine reacts, here chlorine is excess of chlorine to form bromine pentafluoride. So these are preparations of interhalogens like chlorine fluoride, iodine chloride, chlorine trifluoride, bromine trifluoride, bromine pentafluorides. So these are directly combined or action of halogens on interhalogen compounds at various ratios, at various temperatures. These are the preparation methods. Their properties, these are all are covalent nature as well as diamagnetic nature also. And also, except here ClF, remaining all are volatile solids and gases. Sorry, volatile solids and liquids. But ClF only gas state substance. ClF only gas. Remaining all are volatile solids and liquids children. Next. These physical properties, nothing but interhalogen compounds, physical properties are intermediate between the constituents of the halogens. For example, so these physical properties of chlorine fluoride intermediate between chlorine and fluorine. Like ClF3, physical properties are intermediate between chlorine and fluorine. BrF3, physical properties are intermediate between bromine and fluorine. That's why every interhalogen compound physical properties are intermediate between corresponding halogens. But here exception of melting and boiling points. Here melting and boiling points is slightly higher than that of the corresponding halogens. Okay children. Whereas in chemical properties, interhalogen compounds are more reactive than the corresponding halogens. Except fluorine. Why? Because here interhalogen compound bond, that is XX dash bond, is weaker bond when compared to halogens bond. Halogen bond is XX. XX dash bond is weaker bond compared to XX bond. This is called interhalogen compound. This is called halogen. So here interhalogen bond is weaker bond than corresponding halogens bond, but exception of fluorine-fluorine bond, because of fluorine-fluorine bond is a weak bond, can easily to broken down. That is why in interhalogen compounds compared to halogens, interhalogens are more reactive than the corresponding halogens, but except fluorine molecule. So fluorine molecule is again weak bond only. It becomes more reactive than interhalogens. These are interhalogens undergoes hydrolysis to form the products halides, ion, as well as formation of one more compounds are here. Hypohalite from XX dash, halide from XX dash 3, halide from XX dash 5, perhalide from XX dash 7. Understand children? This is XX dash type of halide. Suppose a XX dash halide undergoes hydrolysis, one of the product is a halide product as well as hypohalite products. Then take German formula. XX dash undergoes hydrolysis. This is HX dash. Further dissociate to formation of a X dash minus. This is called halide ion. HOX. This is hypohalide. So further dissociate into formation of H plus and OX minus. That is called hypohalide ion. So that is why here formation of the compounds are whenever undergoes hydrolysis, halide ion as well as hypohalide, halide, halate and perhalate respectively. Here XX dash, XX dash 3, XX dash 5, XX dash 7 type of interhalogens. But which halogen corresponding to halide ion? Which halide ion is corresponding to here? Always is a smaller halogen formed in the form of halide ion. Whereas hypohalide ion is derived from larger halogen. For example, we can take here ClF5, it undergoes hydrolysis. ClF5 is a type of example, X dash type of interhalogen. It is undergoes hydrolysis to form halide ion as well as halate ion. Here halide ion produces from smaller halogen. Which is smaller halogen here? Fluorine. So that is why here the formation of halide ion from fluorine. Halate ion derived from chlorine. Because chlorine is large size. So here very important point children. Halide ion produces from always smaller halogen from interhalogens. Whereas halate ion produces from larger halide, a larger halogen element. So here chlorine and fluorine. Fluorine is small halogen. It produces halide ion. Chlorine larger. This one. It produces halate ion. That's why ClF5 undergoes hydrolysis. One of the product HF, one more product here HClO3. Here HF is called hydrogen fluoride. This corresponding ion is called fluoride ion. That is called commonly halide ion. Like that HClO3 is called chloric acid. Again dissociated in formation of chlorate ion ClO3. Commonly known as halate ion. So understand children here. So ClF5 undergoes hydrolysis, fluoride ion as well as chlorate ion is formed. Fluoride ion produces from fluorine, chlorate ion produces from chlorine. Because chlorine is the large size, fluorine is a small size like that. So it is very important. In asking the competitive point of view also, here ClF3 is given, ClF5 is given. Like that can take ClF3 also. ClF3 undergoes hydrolysis. Which products are called here? One is HF, one more here HClO2. So HF is corresponding fluoride ion. Here HClO2 corresponding ion is ClO2 minus ion. So this is called fluoride ion. This is called here chloride ion. So here chloride ion produces from small halogen. Chloride ion produces from larger halogen. Understand children? So like that, always your interhalogen compounds are undergoes hydrolysis. Always halide ion produces from small halogen from interhalogen compounds. Here another one, here the formation of either hypohalide or halide, halate, perhalate derived from larger halogen children. Okay, so that is the hydrolysis of interhalogens. But what are the uses of interhalogen compounds? These are used for non-aqueous solvents. That is one of the important. Next, here one of the interhalogen compound BRF3, bromine trifluoride, used for fluorinating agents. Like that, here bromine trifluoride as well as chlorine trifluoride, both are used for here preparation of uranium hexafluoride from uranium 235 isotope. So that's why the equation is uranium plus ClF3 gives rise to uranium hexafluoride. What compound is formed? ClF is formed. So that is the use of interhalogen compounds children. You see children, now go to discuss about the preparation, properties and uses of chlorine elements. Now first we discuss about the preparation methods. Various methods are there. First we discuss about the laboratory methods. First three methods are laboratory methods. So one of the method here, chlorine prepared in the laboratory by action of HCl, hydrochloric acid, on manganese dioxide. Here manganese dioxide reacts with hydrochloric acid, constant hydrochloric acid, by heating to form the chlorine gas, as well as the byproduct is here manganese chloride also. However, instead of the hydrochloric acid, by using mixture of common salt and constant sulfuric acid also. So if you are using common salt, nothing but sodium chloride, and constant sulfuric acid, by action of manganese dioxide, also have the liberation of chlorine gas, along with their byproducts manganese chloride, sodium hydrogen sulfate, and water is formed. Next, action of hydrochloric acid on potassium permanganate also. So potassium permanganate reacts with the hydrochloric acid, again here liberation of chlorine gas, along with their byproducts are potassium chloride, manganese chloride, and water molecule is formed. So these are the methods are laboratory methods, children. So in laboratory methods, the preparation of chlorine by using hydrochloric acid and action of here manganese dioxide or here potassium permanganate. And instead of hydrochloric acid, by using here table salt or common salt or sodium chloride with concentrated sulfuric acid also using. Okay children, next goes to manufacture method. Industrially, how to chlorine prepared? Here, one of the method is called, named as specifically Deacons process. Deacons, D-E-A-C-O-N-S, Deacons process. In this process, oxidation of hydrochloric acid by atmospheric oxygen in the presence of cupric chloride at 723 kelvins. In this process, the cupric chloride acts as a catalyst. Here hydrochloric undergoes oxidation by using oxidizing agent, which one? Atmospheric oxygen. So therefore, hydrochloric acid undergoes oxidation in presence of catalyst at 723 kelvins. Chlorine gas is liberated, children. This is one of the manufacture method by industrially. The name is called Deacons process. Very important, children. Explain the manufacture of chlorine by industrially. The name is called Deacons process. And one more method also using by industrially manufacture method, electrolytic process. Here one of the electrolytic method is named as Nelson cell method. Nelson's cell method. In this cell method, using electrolyte is brine solution, children. Brine, B-R-I-N-E, nothing but 10% sodium chloride solution is called brine solution. That is as a electrolyte. Now passing the electric current through the electrolyte of sodium chloride solution, 10% sodium chloride, how many? Water only. So these two molecules are dissociated into formation of the corresponding ions, sodium ion, chloride ion, H plus and OH minus ion. So finally, in electrolysis what happened? Two cations are formed, two anions are formed. So these cations are reached to cathode, anions are reached to anode. Here two anions, only one is preferential, undergoes oxidation takes place. That's why here as per electrochemical series, as per electrode potential values, here chloride ions readily undergoes oxidation takes place. So therefore oxidation of chloride ion, here liberation of chlorine gas, as well as here cations, Na plus and H plus. The preferential here, H plus ion undergoes reduction takes place due to reduction of hydride ion, liberation of hydrogen gas. So finally children, which products are formed? Chlorine gas is liberated anode, hydrogen gas is liberated cathode, as well as here one more the byproduct also formed here, sodium hydroxide. It's all. So because of remaining two ions are there, Na plus ion and OH minus ion. These two are combined together to form one more chemical substance, sodium hydroxide. So in finally children, in Nelson cell method, what are the products are obtained? Chlorine, hydrogen and sodium hydroxides. Understand, children? So, this is about the chemical reaction takes place at anode and cathode reactions. So, this is also one of the industrial method. It is named as called Nelson cell method. Very important, children. See, children, we discuss about the properties and uses of chlorine. Here, chlorine is a greenish yellow gas as well as is a pungent and suffocating odor. It is highly soluble in water. It is reacts with most of the metals and non-metals to form the corresponding chlorides. So, give some examples here. Chlorine reacts with aluminum chloride. Chlorine reacts with iron, ferric chloride. Here one doubt. Sometimes your metals reacts with chlorine form lower oxidation state compounds like higher oxidation state compounds. For example, your iron reacts with chlorine form ferrous and ferric, but they are most preferable to ferric chloride only. Why? Because the ferric chloride is the stable form. Like copper reacts with chlorine, they are preferable to cupric chloride, not cuprous chloride. So like that, always your metals are combined with halogen, the preferable to stable compounds are higher oxidation states of the compound, like ferric chloride, like your cupric chloride, iron chloride, mercury chloride, like that. Whereas, it reacts with some non-metals also. Phosphorus reacts with chlorine, form phosphorus dichloride. Sulfur reacts with chlorine, form sulfur monochloride. Hydrogen is more affinity with chlorine to form hydrochloric acid. Like your hydrogen sulfide reacts with chlorine, form hydrochloric acid plus sulfur. Here, one of the hydrocarbon C10H16 alkane reacts with chlorine, finally form carbonyl as well as hydrochloric acid. Here, chlorine reacts with ammonia also. There are two conditions. Whenever chlorine reacts with excess of ammonia, this is very important, children, asking the properties. What happens? Chlorine reacts with excess of ammonia. Here the product is ammonium chloride and nitrogen gas is liberated. Whereas excess of chlorine can be, the product is here nitrogen trichloride and hydrochloric acid is formed, children. It's very important. Excess of ammonia, ammonium chloride. Excess of chlorine, nitrogen trichloride. Your byproducts are hydrochloric acid, your byproduct is nitrogen gas. Like that. Action of NaOH. Your chlorine reacts with cold dilute NaOH solution to form chlorides. The corresponding compound sodium chloride and sodium hypochlorite. NaOCl, hypochlorite. HYPO chloride, HCHLO-RITE, children. Hypochlorite. Hypochlorite formula OCl minus ion, but sodium hypochlorite formula NaOCl plus H2O formation. Whereas condition here cold and dilute NaOH. Now, children, this reaction observed, your chlorine oxidation number is 0, but your chlorine oxidation number minus 1, in this chlorine oxidation number plus 1. Then what happens, children, here? One element, reactant element undergoes reduction, this reduction reaction, again same element undergoes oxidation reaction takes place. That is why this is an example of disproportionation reaction also, children. Like that, your chlorine reacts with hot and concentrated sodium hydroxide. Here one more common product here, sodium chloride and sodium chloride. But byproduct is here, one more is sodium chlorate. This is NaClO3, chlorates, CHLORATES, chlorates plus water molecule. So what is the difference observed here? Cold and dilute NaOH, sodium hypochlorite, hot and concentrated NaOH, sodium chlorate with sodium chloride and water molecule common. It is also a disproportionation reaction, children. Your chlorine oxidation number 0, your fluorine oxidation number in NaCl minus 1, your chlorine oxidation number plus 5 in NaClO3. Again, what happened? 0 to minus 1, reduction reaction. Again 0 2 plus 5, oxidation reaction. So see children, your reaction with chlorine on NaOH, both are disproportionation redox reactions. Because only one reactant element, that is chlorine, undergoes oxidation and reduction takes place simultaneously. So that is the action of your NaOH. It is also very important children. Next, lime. Here, calcium hydroxide. Lime is nothing but calcium hydroxide reacts with chlorine to form the bleaching powder. Bleaching powder. So the bleaching powder, chemical formula is CaOCl taken twice. This is called calcium oxychloride. Calcium oxychloride or calcium hypochloride plus calcium chloride and H2O. So finally, the composition of the bleaching powder, very important children. What is the composition of the bleaching powder? Calcium oxychloride, calcium chloride and calcium hydroxide of hydrated substance. So this is the composition of the bleaching powder. You have observed the reaction also. You have calcium hydroxide reacts with chlorine, product is calcium oxychloride, calcium chloride, water, along with you have some insufficient undissolving of calcium hydroxide also. That's why the composition of the bleaching powder, calcium oxychloride, calcium chloride, calcium hydroxide with water molecules. That is the composition here. Next, chlorine reacts with hydrocarbons like saturated hydrocarbons as well as unsaturated hydrocarbons. So if it is chlorine reacts with saturated hydrocarbons of methane, product is methyl chloride. Here what happened here? Substitution reaction takes place. Whereas unsaturated hydrocarbons reacts with chlorine at room temperature to form addition product, that is C2H4Cl2, that is called dichloroethane. Dichloroethane is formed. So that's why here saturated hydrocarbons reacts with chlorine, substitution reaction takes place. Unsaturated hydrocarbons reacts with chlorine, addition reaction takes place children. Next, chlorine is highly soluble in water. Due to soluble of water, after solving here, the chlorine water is on long standing, the color of the yellowish greenish yellow color becomes here loses. Why? Because here the chlorine water on decomposition to hydrochloric acid and hypochlorous acid, HOCl, that is called hypochlorous acid. See children the equation, Cl2 plus H2O, HCl plus HOCl. HCl is called hydrochloric acid, HOCl is called hypochlorous acid. But this is hydrochloric acid as well as nascent oxygen. Nascent oxygen means just readily releasing of oxygen or just born oxygen. Due to your liberation of nascent oxygen, your hydrochloric acid solution means here chlorine water, it behaves as a chlorine gas, behaves as a oxidizing property as well as bleaching property. It acts as oxidizing agent and bleaching agent also children. Why? Because chlorine is dissolved in the water. The chlorine water on non-standing dissociated into hydrochloric acid and hypochlorous acid. Again hypochlorous acid unstable, dissociated to nascent oxygen. Due to formation of nascent oxygen, it acts as a oxidizing agent as well as bleaching agent. That is why your chlorine gas is also used for the sterilization of the drinking water. It is acts as a bleaching agent. Your sterilizing of the water or purification of the water, you are using the chlorine. Okay children. Now see children here, some more properties of chlorine. Chlorine acts as a oxidizing agents as well as bleaching agents. So that is why it oxidizes ferrous salt to ferric salts, sulfide salts to sulfate salts, as well as your sulfur dioxide is oxidized to sulfur trioxide, iodine is oxidized to iodate. Whereas in the presence of water, your sulfur dioxide is oxidized to directly sulfuric acid, like iodine is oxidized to iodic acid also in presence of water. Whereas in absence of water, sulfur dioxide is sulfur trioxide, iodide to iodate. But in presence of water, sulfur dioxide is converted into sulfuric acid, iodine converted into iodic acid, children. So now you observe the reactions. Ferrous sulfate, your oxidation state of iron, plus 2. So with H2SO4 converted into ferric sulfate, your oxidation is plus 3. Like sodium sulfite, SO3, your oxidation to sodium sulfate. Like SO2 in the presence of water to give rise to sulfuric acid. Like iodine in presence of water reacts with chlorine, iodic acid. Like that, here properties. And also it acts as a powerful bleaching agent also due to liberation of nascent oxygen. Why it acts as bleaching agent? Due to oxidation. So that is why your chlorine water you dissociate into hydrochloric acid and hypochlorous acid. Further it dissociated into nascent oxide. This nascent oxide is causes for the bleaching of colored matter into colorless matter. So these are the oxidizing and bleaching properties of chlorine. Next, but what about uses of chlorine? Here mainly chlorine is used as a bleaching agent in wood pulp as well as cotton as well as textile industries. Wood pulp means paper industries. It is also used as bleaching agent in cotton and textile industries. Next, it is also chlorine gas is also used for the extraction of noble metals like iron and platinum. Next, here chlorine also used for the manufacture of dyes, drugs, and some more organic compounds like carbon tetrachloride, chloroform, as well as here using for the preparation of your methyl chloride, etc. like this. Preparation of organic compounds also children. Next, mainly it is used for the sterilization of the drinking water because of your liberation of nascent oxygen to kill the bacteria present in the water. That is why it is used for the sterilization of the drinking water. It is also used for the preparation of some poisonous gases, children. What are poisonous gases? Some of the example here: phosphazine. Phosphazine chemical formula COCl2. The chemical name carbonyl chloride. Next one, tear gas. The chemical formula CCl3NO2. It is named as nitro trichloromethane. Nitro trichloromethane. The chemical name of tear gas. Next one, mustard gas. Mustard gas formula here see here Cl CH2 sulfur central atom CH2CH2Cl. So it is also prepared by using chlorine gas because of here both the ends are chlorine atoms. In between two ethylene groups, so CH sulfur atom is linked together. That is here sulfur linkage of the gas, mustard gas. Especially this mustard gas is in war gases also. So these are the uses of chlorine. So and finally preparations. Physical, chemical as well as chemical properties are studied, children, here. So this is about the chlorine. Here the chlorine is the most important, children, here. Asking preparation methods as well as chemical properties also. In chemical properties, the most important is action with the ammonia, action with the sodium hydroxide. Here action with the some oxidizing properties. Sulfur dioxide, like action with iodine, they reaction with C10H16 hydrocarbon, like that. Here also action with the ferrous salt, ferric salts. These are most important chemical properties, children. Sometimes asking the board point of view as well as in competitive point of view also. So this is about the chlorine preparation and properties.